Thank you very much. Essentially, we put this presentation together to sort of share with some of the other practitioners and the people who are, considering their next NetFlow implementation, and share some of the successes that we've had with Lancope and some of the things that we've done in our environment, specifically around our playbook and our detection mechanisms. So we wanted to jump right away into a real-world use case that's fairly recent on everyone's mind and let them know some of the value that we've gotten from Lancope in the past. So Heartbleed, April 8th, 2014, if you don't remember it, essentially it was a bug in OpenSSL that allowed people to pull information from the SSL library. So all of the information that you really wanted to protect was exactly what was exposed. There were some signatures that were released for it, but it took a little while to actually get those out there and deployed to IDS systems. But with NetFlow and with Lancope, we had protection immediately. And so what we did in preparation was we actually scanned about 1.2 million IP addresses external to Cisco and found that about 300 of those actually needed to be fixed. We developed some signatures for SourceFire and the Cisco IDS systems and deployed the signatures to our IDS. Those were, honestly, the signatures that first came out were hit and miss. Anyone who may have deployed the bleeding edge signatures, some of them were actually disabled by default. And it was a little bit of a pain to determine what was a false positive versus what was actually a malicious connection to your system. And so one of the features of StealthWatch that we really enjoyed was just using the default concern index. So an example of what our process looked like is when one of those IDS signatures fired that we weren't quite sure of, we were able to actually go run a StealthWatch report for that actual IP address and take a look at it and pull it up within StealthWatch, look to see historically how many connections it had made to that website. And then what's great is you could actually look and see what the host alarms looked like. And here you can see that there are no concern index events for that host. And so this is StealthWatch's way of saying we don't see anything bad coming from that IP address. It hasn't triggered anything with our algorithms that says it's malicious. So this is, in our books, this is a benign host, and we were able to do this for all of those events that fired and implemented it into our playbook. And just for some context here, here's what a malicious host looks like. So, exact same report output, but we can see that this host is repeatedly hitting lots of our infrastructure, and anyone who has looked into Shodan in the past knows that it's sort of an internet scanner looking for vulnerabilities and trying to map them out. So it's no surprise that when I actually look at the host snapshot and look at all of the alarms for that Shodan host, we actually see lots of triggers or lots of alarms being triggered, and the concern index is pretty high, and we can see that it's been address scanning our 443 ports. So it's a really quick and easy way to verify that that is indeed a malicious host. And then at this point, it's easy for us to throw a BGP black hole in and cut off communication for that host across all of Cisco.
All right. So now we're going to talk a little bit about the history of NetFlow at Cisco and NetFlow in general. So the common analogy is a good one. It's fit, and that is that NetFlow is really just similar to a telephone bill of your data. That is to say, it is information about your data and not the data itself. So with that in mind, you get source, dest, IP, port information, the number of flows, the number of packets in the flow, and the time and date stamp. And with that, you can actually retain quite a bit of information with a fairly small footprint. Currently today, we are averaging 21 billion flows within Cisco that we are retaining, and we are using full NetFlow. So there are multiple ways to deploy NetFlow and to enable it. But as a security team, and we want forensic data, we want full NetFlow. So that is to say, we don't look for sampled NetFlow, which has its use cases in things like capacity planning and so forth. But when it comes to security, we don't want to essentially roll the dice and hope that we saw the flow that's related to the incident that we're looking at. So we have not always used Lancope. We have a history of tools. These are three that our team has background with, but certainly there are more out there. But going chronologically for us is left to right. So with the OSU FlowTools, that's what we first used, open source solution from Ohio State. And at the point in time that we were deploying it, it's important to note that it was a v5 protocol. It did not support further or latter versions of NetFlow data. So although it is compliant with V6 today, at the time that we deployed it, it was not. So that was one of those things that's a gap for us. And as Cisco, we fully participate in things like IPv6 World Day, World Week, et cetera. As you would imagine, IPv6, gets stood up within Cisco regularly. So that was a gap. It was primarily command line. Natively it is command line, and it just had some gaps there. We've also used NFDump, which is another open source solution, again, V5 and up support, but still, pretty CLI centric, and so that presents its own challenges. In 2010, we began deploying StealthWatch, which gives us the ability to actually have a GUI as well, to widen the range and ease access to the tool for multiple users. So life before StealthWatch, we'll get in the Wayback Machine and take a look at it. Like I said, OSU FlowTools, but we had many systems running in parallel, and the administration related to that was difficult because we had collectors, each router having to export to each collector. So you have a lot of just making sure that feeds are in place and so forth. It's a lot of physical storage, and also we didn't have any ability to really do flow aggregation or deduplication. So again, that adds to the problem of how much storage you're going to need to store the amount of flows that we were talking about. So it was workable for some time, but this was kind of what pushed us to look elsewhere. So, just recapping across all of it, we had the support of open source tools, training the staff. Feature requests, anything that is an open source tool, depending on who was actually doing the development, you may or may not see that feature request come through anytime soon. And in addition, you're going to have evolution of the underlying protocols underneath it. I mentioned IPv6 becoming more of an issue for us. Or more of a concern with our traffic, but also, moving to NetFlow V9 and looking at things like flexible NetFlow and things like that. Those are going to happen. So the idea of the open source tools and custom tools, it became more and more of an effort as we tried to absorb those new needs. And also, we did have a problem with just being able to understand when we had a loss of a feed and to do it well and consistently alert upon it, et cetera. So just an example of what we were looking like when we had OSU FlowTools. Again, this is a native CLI kind of approach, and your users may or may not be comfortable with Unix, but it is usable, and some people are always going to want the CLI, to be honest with you, but fairly strict requirements. One of the nice things that you can do with the CLI is you actually have the ability to write iOS type of ACLs. So you could run queries against multiple IPs, over a set amount of time, et cetera. But again, not the most intuitive for all users. So to address that issue with accessibility, we did develop this internally. We developed a tool that is more of a GUI thing, which is essentially what you just saw, but put into a GUI interface that people could jump into. Again, serviceable, but it still required, more people developing this, to map to new functionality within OSU FlowTools, et cetera. So it was kind of a consistent concern with resourcing. All of which has led us to start deploying StealthWatch. So let's talk about where we look for flow data. Essentially, I think we'd all like to see flow from everywhere. I mean, theoretically, that sounds like the best idea if we're talking about visibility and east to west traffic. But at some point, you have to make the right choice and balance, the correct level of visibility with the overhead, storage costs, et cetera, of having flows from absolutely everywhere. So what we've done is, I would say 85, 90% of our flow traffic comes from existing network choke points. For us, the important ones of note are ISP gateways and data center gateways. So that is, things going in and out of Cisco and things going in and out of our data center where a lot of our IP sits, a lot of the crown jewels to our company. So that's the overview. In reality, we also have other places. We will have things like acquisitions that come into Cisco, and we don't have visibility there. So we may do targeted monitoring within an acquisition. We may also have particular segments where we have, it could be, personally identifiable information that resides somewhere. It could just be something that's highly confidential that represents a high-risk site, and we can deploy and look for flow data from, more targeted types of environment. But at a high level, all of this data is going to come back and live in the Lancope flow collector, which we will then interface via the SNC. So an illustration of how we deploy this at Cisco, I think this is beneficial just to take a look at. So within a region, so if you look at that region 1, going up the stack. So we have exporting devices. Most of the exporting devices are network devices, and they're Cisco devices. But we also live in a world where not everything can give us the NetFlow the way that we want it. So, even at Cisco, we could have acquisitions where companies could be using, small Soho-type networking gear that doesn't even speak or understand NetFlow data. It could be that the Cisco box that you have could be like something like a 494810 gig, which simply doesn't have any more room left in it to create and export NetFlow data. So exporting devices, like I said, are primarily network devices, but we also have started to use both Lancope flow sensors and Cisco NetFlow generator appliances, the NGAs. And if you're not familiar with those boxes, really their entire purpose for being is to consume traffic via a tap or a span and create flow data and export it. So both of those really serve the same purpose. So we have our exporting devices within a region, and they feed into the flow replicators. Again, this is a Lancope appliance, and I just want to take a moment to tell you our use case for them and why we like them. Organizationally, within Cisco, we are not a part of IT. So we don't directly control the configuration of the exporting devices, particularly where they're network devices that are used for traffic. And so what that means is that if we ever had a change where we wanted to influence where a device was exporting to, we would actually have to follow our change request. And, that's a fairly lengthy lead time. It's 10 days within Cisco for a standard change request that they need, prior submission of that change. So that's pretty lengthy. So instead what we do is we export everything to flow replicators, which are, a 1RU Lancope appliance, and then we control the configuration on the replicators. This is good for us because it allows us to do dynamic balancing, between flow collectors, or, if one is getting way too much data because, some exporting devices started, seeing much more traffic or more interfaces were turned up. So it allows us to shift that traffic around as we see fit, and we're outside of having to go through IT's change request. And it doesn't, it's not in line, so to speak, so it's not affecting any throughput for production services. So we like the flow replicators, and the other, because we can dynamically move stuff around. And the other thing I will say is that for our team, we're pretty consistently asked to evaluate a lot of tools, and I really like production data where we can use it. So another use case for us is we use the flow replicators, and we send production traffic potentially like into our lab to use with these tools that we're constantly evaluating. So all the traffic flows through the flow replicators and then ultimately to the flow collectors within region. This is where the flow data lives and persists. And then as a user, you're going to interact with the search head. It's called search head here because this is a common infrastructure we use for multiple things. But that search head you can think of as our SMC. So that's where the user will go in, define what their query looks like, and then the SMC in turn reaches out across all the different collectors in all the different regions. What does it look like by way of the amount of hardware that we have currently? Well, here's the readout. I won't read them out to you. But, keep in mind that the flow collectors, we've been deploying since 2010. And so we have a range. Currently, actually, we only have the flow collector 1000s and 2000s. We don't have any of the 4000s yet. But I suspect once we hit, whenever these things go, end of support or end of life cycle, I would expect us to be tearing out some of the 1000s and replacing them with larger boxes and consolidating down a bit as well. So I told you the 21 billion NetFlow number, and that's full NetFlow again. So what do we have in terms of retention? Well, it's important to understand that we expect with NetFlow that we have 90 days retention. So that's what we shoot for. So just the high-level readout for us is we're exceeding that with the infrastructure that we've installed. You can kind of see where our major regions are. So those are the numbers that we're hitting today. So we are exceeding our target by at least 33%.
So one of the questions we get asked a lot is why we chose Lancope, why we moved away from open source, why we didn't choose another vendor. And I want to take some time to give some of the top answers for us. And so to really dive into that, we have to think about the problems that we had before Lancope. And so one of our biggest problems, and this is how those numbers are so high for retention, it being solved essentially on the Lancope side. The real challenge is flow timeouts and duplication of flows as it goes across the infrastructure. So if you look at the way NetFlow actually works, if there's a flow from a client to the internet, and there's a lab gateway and an ISP gateway, and that flow is 90 seconds long, flow timeout, by default, the way it works in the protocol, it'll actually split up that flow into 3 separate 30-second flows. It does this to make sure that the device doesn't keep flows in memory longer than it has to, and it's just the way NetFlow works, and there's a lot of advantages to it. The disadvantage is that if you have 2 devices and you have 3 flows coming off of every device, you end up having a lot more flows that you have to store on the back end. In this particular case, you have 6 flows that are created from one 90-second connection out to the internet. And so you can imagine if a flow is lasting several hours, which many of them do, you can have a whole lot of flows you have to store in the back end, which leads us to the business benefit number 1. This one is pretty huge for us, and that's storage capacity. With Lancope, what it actually does with StealthWatch on the back end is it actually takes those 3 flows from Lab Gateway number 1 and those 3 flows from from ISP Gateway number 1, and it throws them into one single record within StealthWatch. And this is actually, if you run the flow query, this is an example of what that actually looks like on the back end. So you'll see one record showing the flow as it crosses over the network. What's great here is not only do you get consolidation of one table in a database that's filled up with all of the devices that a flow crosses over, but you get to see your actual network trajectory. So you understand not just when the flow went out and how many packets a second it was and all that sort of stuff, but you also know exactly which path it took over the network, which can be really important when you start looking at things like DOS attacks that are internal going outside, and you want to really understand the actual path that packets took over the network. It's huge there. So it cannot be explained enough how awesome it is to be able to go back and look at 90 days worth of retention in the worst case scenario from that slide that Paul had. Before we had this capability with StealthWatch, we were with that 20+ terabyte infrastructure of OSU FlowTools, we were only keeping a week to 2 weeks in many cases. So just having these algorithms in place really helped us a lot. The next business benefit, Paul mentioned it a little bit when we were talking about some of the challenges with OSU FlowTools. It's really ease of support. The fact that with StealthWatch we deploy a single box and we can point flows that are both V5 and V9 that include IPv4 and IPv6 all at one device and have it pull all of those flows together is huge. with most of the open source tools, you have to have separate listeners for different protocol versions set up, and you have to break out the actual storage locations to different physical storage locations if you want to be able to query for, say, V5 versus V9. And it really becomes a really heavy administrative burden to do that. And you end up having to pay someone a lot of money to support an open source tool when a lot of this stuff is built into, StealthWatch out of the box. So the system administration, I can honestly say, as long as we've had StealthWatch from 2010, there's been a couple of minor issues that have been hardware related, and it's a pretty quick and easy fix, and the systems are up and running, and there's no loss of data. That was not necessarily the case with OSU FlowTools or NFDump. There was lots of stuff that was sort of a pain in the butt to keep up with. System patches. You update. Heartbleed's a great example. With Heartbleed, you had to upgrade the OpenSSL libraries. Anytime you do that on a system, you don't really know what upgrading one library is going to impact, and there's a lot of headache that goes into keeping things up to date. Here, the burden is all on Lancope for support. And it's just, updating the systems is really as simple as dropping a binary into the StealthWatch GUI and saying go. So pretty quick and easy. And the last thing that's really important, and again, Paul mentioned this briefly, is alarms built in for monitoring of lost flows. When we had all of those systems deployed with multiple routers pointing to multiple collectors, we didn't really have a great way to figure out when a system would suddenly just stop sending flows. It was sort of lost in the noise because there were so many of those going on. Here's an example within StealthWatch of 2 devices that have actually stopped sending flows and have triggered alarms. And so you can actually easily monitor for when a device has previously been sending a large amount of flows or an average amount of flows, and it starts losing those flows. It sends out a simple alarm. You can send SNMP traps. You can export those alarms to Splunk, which we talk about a little bit later. So you can actually build real monitoring around losing flows from devices you expect to have. Realistically, what happened to us lots of times is we would have a case that popped up, and we would be looking for the flows across the NFDump or OSU FlowTools infrastructure, and we wouldn't realize we lost flows until we weren't getting returns for our queries. And then as we dug deeper, we'd find out that someone made a change to a template or an ACL was put in place. It's much better to find out when you lose those flows than when you're in the middle of a case. And business case number 3 is really ease of use. For us, this is huge. We can take people that don't have a background in Unix or even necessarily understand what an ACL is, and they can log into the system and they see a nice graphical representation of the flows. You have the peaks and valleys in here, and you can honestly get a real understanding of what your flow rate looks like for, either a specific host group or across your whole enterprise. And for anyone who maybe hasn't used Lancope StealthWatch in the past, the idea of host group to us is really attractive as well. So the business benefit of a host group is essentially it's a list of IP addresses and subnets, and so you can do really fine-scale tuning and get more relevant information for that particular set of hosts. And all of that is gathered and displayed in these nice panels that show you for that particular host group what your traffic looks like. And there's been, yeah, it's pretty. A lot of people say big deal. You get a pretty representation. You can get that with cacti and some of that other stuff. What's really nice is you can actually drag over the area that looks interesting and zoom in on it. And again, that seems like it's not really that great of a feature, but when it comes down to it, people, understand things visually at a level that's hard to replicate with something that's in a text-based alarm or in a system that's not visual. So a real-world example of where this has helped us in the past. We had a case like this come in, and we saw lots of peaks and valleys, and it was actually escalated to us as a DOS attack. And so, we went into StealthWatch and started poking around. We really wanted to understand what we were seeing. And as we drilled in, we noticed that if you hover over the actual colors, it shows you what the protocol is. And the large spikes were actually net backup traffic. And as we started to dive into it a little bit more, what we found was that an entire data center of a company that we had acquired had set all of their backups to run at the same time every day. And so every host was trying to back up everything it had, and it was all traversing this particular data center gateway, which just wasn't set up to handle that kind of traffic. Again, that was buried in the noise, but visually it was easy for someone who was a fairly junior analyst to go in and find exactly what was going on. So, I mean, it's huge when you can have a tool do that sort of work for you. And just to give you some more understanding of how simple it is on the StealthWatch side, you know, this is our most common use case. You know, looking at an IP address and trying to figure out how many flows that IP address has had between different zones and take a look and see what that traffic looks like. And within StealthWatch, you simply put the IP address in here and hit OK. There are a couple other things. You know, you can choose the actual host group you want to search as well. So you can look for just this connection going to specific host groups. And here we say outside hosts. And so what we're doing is taking this IP address and saying we want to see all connections it's made to the internet, essentially. There's also a default to 2,000 flows returned maximum. You can easily uncheck that. A lot of times you don't necessarily want to see more than that, but it's pretty easy to uncheck and get all of the flows going out. And this is a lot easier than say, doing the exact same thing with OSU FlowTools. And so, you know, the example with OSU FlowTools is you create the ACL, and then you have to apply the ACL to, you know, several different piped commands together to get the output. So it's just much easier, honestly, to do this. And the other thing, which is a pretty huge business benefit that we didn't mention, is this is all stored in a database. You know, it's much quicker to return. Some of these queries could take hours or, you know, potentially even days to run. You know, they're much quicker on the StealthWatch side. So the great part is this is what the output of that looks like. You have a nice, well put together representation of the flows. You have the client host and the server host that it's connecting to. It also shows you the default host groups that they belong to, how long the flow was, what applications they use. The reason it says unclassified here is it's assuming it's HTTP based on the port. If you actually have, say, flexible NetFlow or a flow sensor device in line that can actually see the underlying protocol, it will classify it correctly, and it'll even say things like, you know, the application is Facebook if it sees that someone is visiting the URL for Facebook and those sorts of things. And then the total bytes transferred is definitely really nice to have. So just if we zoom in on one of the rows here, again, you can see one of the nice features is you actually get to see GeoIP information. So it'll actually show you the country, the DNS record, the whole 9 yards, as well as the total pipe and the total amount of traffic transferred. And so that's actually huge. You know, GeoIP information, there's been times in the past where, you know, we've had interesting cases, and you know, if you have someone that's sitting in the U.S. and you suspect that there's some interesting behavior going on, but you're not sure, and you just look at all their flows and sort by, you know, the server zone. Not saying that it's always the case, but a lot of times, you know, if you scroll to the bottom of that and start looking at stuff that's not in the country of the user, you know, you start with something more interesting to investigate. And a lot of times, if someone's sitting in the U.S., you know, they may not be browsing, you know, a website in China all day long. You know, there's certainly cases when they do, but it does give you a breadcrumb to start your investigation with. And there's been several times when we found interesting command and control traffic by doing some of the simple stuff. But realistically, there's a lot of stuff that's not simple stuff that Lancope does. So analytics, you know, these are huge. Essentially, if you don't have the built-in Lancope alarms, you have to actually write algorithms yourself to look for all of the stuff that's built into it. And so, you know, here's just an example of suspected data loss, high file sharing index, maximum flow served. All of these, from the day that you plug in StealthWatch to your network, all of the flows that are going through are actually being picked up and are being populated in the tables. And like I said, you can actually send these alerts out to other systems as well. So if you have a third-party SIM that you want to integrate with, but you don't want to send all of your flows, it's pretty easy to have these alarms firing and actually have them sent into that system. And so when we start talking about use cases, what do we do with those alarms? What do we do with StealthWatch? You know, essentially, command and control discovery is what got us most interested in NetFlow in the first place. And what that looks like is fairly generic across all NetFlow systems. So, you know, you detect command and control either through, say, forensics of an internal system, a piece of intelligence. There's lots of ways to figure out an external command and control host and what internal host is actually communicating with it. The next piece of the puzzle that you can really only do with something like either full packet capture or NetFlow is run a query for all of the other internal hosts that are making the connections to the external systems, and then also look to see what systems those internal hosts have in common. And you can sort of develop, you know, peer-to-peer networks for the command and control servers externally. You can do that, and I mentioned you can do that with full packet capture, but realistically, the problem with full packet capture versus NetFlow is that it's so much data. You know, you have a lot more data to look through. It's not summarized. It's not all put together. So it's not easy to look through, you know, terabytes and terabytes of data for a small connection. Lancope, you're looking at the metadata. It's much easier to pull together the metadata and look at it. And there are systems that are full packet capture systems that do some of that metadata, you know, sort of anomaly detection and all that sort of stuff. But, you know, our experience at Cisco, at least, has been that no one else really does as good a job as StealthWatch. And we've been really happy with the way that they actually make that data available for you to view and put that in alarms. So another nice feature, and again, we have lots of different tools that use NetFlow here at Cisco. From the security side, Lancope is, StealthWatch is really all we use for security. And so when we're actually, you know, trying to get a quick and dirty, you know, say DOS detection deployed, we'll go into Lancope. We'll actually take a host group. In this example, you know, we can just take all of the IP address ranges associated with WebEx, drop them into a host group, and set up a relationship alarm within the maps that are in StealthWatch by default. And so what's great about this is you can actually take this host group for WebEx, take this host group for outside, you drag them into the map, and you just draw a line between them. And you say, I now want to have an alarm set up for this particular line. And this alarm is anytime an alarm has more than 450 megabits of traffic and it lasts for more than 5 minutes, send an alert. It's really easy to do. It takes just literally a couple seconds to do this. And then you can also create a second host group called false positives. And anything that is firing this alarm that is a false positive, you just keep adding it to this host group so that when the analyst gets it, they can run a report that says, I want to see all alarms for the WebEx high traffic relationship that don't include the false positive host group. Really quick and easy to do. Another thing that's easy to do with Lancope StealthWatch is just set up, you know, targeted monitoring for data loss. Again, there's lots of alarms out of the box for data loss. Now, realistically, one of the things we'll talk about in a bit is if you turn this on for your entire network, depending on your network policy, you're going to have lots of noise, and these aren't going to be useful alarms. You know, at Cisco, it's not unusual for us to have people that are developing new protocols and using P2P in labs to sort of transfer information back and forth for all sorts of different things. And so if we just turn on all of these data loss alarms for all of Cisco, we would spend all day chasing them down. So what we've done is we've actually you know, chose parts of our network where we have a little bit more sensitivity around what's going on, and there's not as much tolerance for people doing, you know, say protocol development and you know, video sharing and all that sort of stuff. And we apply these alarms specifically to those parts of the network, and we've had, you know, a lot of success there. And so in this example, this is what the actual alarms look like for a part of the network that we actually care about. And so these are all alarms that are going into our SIM, which is Splunk, that are investigated by our investigators and analysts. And again, we can do the same sort of thing where we can do data loss based off of the total amount transferred. Instead of having you know, something generic that says it's this many bytes per second, you can have a smarter alarm that says over 24 hours, we don't want more than 500 megs transferred between this host group and this host group. And so, there's some flexibility in the way that you can actually define those relationships. Host locking is a feature that is, pretty relevant to some of the monitoring that we do within Lancope. And the idea of a host lock is essentially, if you have host group A, you say that it should never ever talk to host group B. And if it does, send a message. So we have, the inside hosts and a known list of command and control servers. And so those command and control servers are updated by an intelligence feed, and anytime there's a connection, a syslog event goes out. Again, this is something that's really easy to set up yourself if you have an external intelligence feed. And in fact, Lancope has integrated into StealthWatch now an intelligence feed, which will automatically update this list of known bad command and control hosts from some vendors who are doing this sort of research all the time. So even if you don't have a team of people that's going out and gathering this intelligence, there are ways within the tool to sort of have this basic host locking set up. And you can also do it for things internal on your network. It doesn't have to be inside to outside. You can say, my Active Directory servers should never be talking to my FTP servers over anything other than port 23 or 21. You can have all that sort of stuff laid out pretty easily, and it all depends on how well you can define your network and how mature your address management is. One other thing I'll mention that's pretty crucial for us is threat intelligence within Lancope. And so when we start talking about cyber, APT, or whatever you want to call it, what we have internally to Cisco is we actually use CRITS, which was developed by MITRE. It's now open source, and it's a tool where you can throw all of your known indicators in and actually give it attribution and all that sort of stuff. It's basically, CRIT stands for Collaborative Research into Threats. And so we have our analysts and investigators actually putting data into CRITS on a regular basis. And that data, is used to prevent, detect, and share externally indicator information. And so this detect bucket is really important for us because it's easy to throw IPv4 and IPv6 indicators into a host group within Lancope and then just do monitoring based on that. So any alarm that fires for a host that's in that sort of critical IP adder-CRITS host group is escalated really quickly to investigators and analysts. And what that looks like on our side, I mentioned we use Splunk. We actually have SMC alarms built into Splunk, and so it's really nice and easy to go into the StealthWatch and configure an alarm to export. When you do that, you can pick and choose what that actually looks like as far as formatting, what information is included. And here you can see there's actually a link to StealthWatch within the alarm itself. So as an analyst or investigator is taking a look at the alarms that are coming in, it's nice because they can simply click here on this piece, and instead of having to launch the full Java UI, they get a nice quick and dirty host snapshot of what's going on. So they don't really even have to move off of Splunk to do their analysis. They can quickly take a look here and say, hey, it looks like this is actually a false positive based on the source and destination.
So one of the things that CSIRT's been looking at over the last 18 months to 24 months is leveraging the API that's made available from Lancope. And I just want to call out and walk through some of these, just to illustrate, ways that we've said, hey, we can't quite get the data the way we want it, or we want to approach it a little bit differently. So the first use case is, the ability to pull all flows for a given time period. And what the limitation there has been historically is that SMC will only permit you to return 400,000 flows per query. And that's quite a bit, and that covers a lot of circumstances. But we do occasionally have investigations or incidents where we need more than that, right? So one of the things that we did is we said, let's take a look at the API, and let's structure it so we will run smaller consecutive queries that fall well beneath the limit, the per query limit, and then concatenate them together. And this is something we've talked to Lancope about, extending what that limit is. But here's a way that we were able to do that pretty quickly, and still have all the deduplication and everything else that Lancope affords us. We also have the ability to upgrade host groups. So Mike mentioned the value of host groups. Actually, I'm going to get into this in the next couple of slides. But the other one I want to talk about here is really, the user attribution piece. So, we have an incident and we have a person who is a telecommuter, let's say, and, they start off the day VPNing from home, then in the airport on the wireless there, then they're at a customer site and they're VPN'd in, and then, they come back to the lab, right? So they have multiple IPs throughout the course of a day, and so it's not about the individual ones, but it's all the different IPs that we need to look for in a query. So we do have a way to go out and find that information. Again, all the IPs associated with a particular machine, and then submit those as a query using the API. So I mentioned the host groups and what we do to update them. Internally, for IP address management, we have a single source of truth, right, that goes out and queries multiple places. But those end up with a structure that you have that says, at a high level, here's all my campus stuff, desktop networks, here's DMZ hosts, data center hosts, etc. That's really powerful contextual information to have. And what we're looking at is a way to feed this directly into Lancope via host groups. And what we've done, again, using the API, is we say, let's go to our single source of truth, create these large, defined functional areas of our network, and push them out. And currently what we're doing is we made a couple of decisions. We only do this once a day. You could certainly do it more times, but once a day seems to be, fairly, it's fresh enough for users that's fine. And what we've done also is just to inform the users of which groups are being updated, we have prepended the names with API zone. So you'll see that they're called API Lab, API DMZ, right? So as a user, I can go in there and say, I have the belief in this, that this is a, update within the last 24 hours and these hosts are accurate. And then from there, you can build more complex host groups. But this could be a way to start out. And it also doesn't prevent users from doing ad hoc host groups. So the same IP can exist in multiple host groups. So again, this doesn't take anything away. This just adds more context for our users to understand what the traffic is that they're looking at. Getting back to Splunk, as Mike mentioned, we use Splunk, and it's central to our workflow. So the more that we can do within Splunk, the better off we are, and more people are going to use it. So one of the things that we developed internally, just using the API, is a workflow where you can take a look at any type of event within Splunk, and you can use this drop-down menu, and you can do a getFlow. And what that's going to do is it's going to give you the flows between the source and dest IP with that event, and it's going to get them for 30 minutes leading up to the event and 30 minutes after the event happens. So basically you end up with an hour of associated flows returned in your browser window. So it doesn't look pretty necessarily, but it's a very quick way for users to pivot to the data. Again, reaping the rewards of of storing the flows within Lancope flow collectors. Again, just having that look back is tremendous, and this just leverages it, and it pulls it out, and it gives that flow information back to the users, and it doesn't break them out of using Splunk, which is kind of their main way to approach the job and where they live and do all their reporting.
And so we wanted to close up with next steps. So if you have not purchased Lancope and spent a lot of time tuning it or given it a lot of thought and just sort of having it sit there out of the box, there's definitely some things that you can do to improve your experience. Number one is obviously find a collection system. We said why we prefer StealthWatch over a lot of the stuff that's out there. It does have a lot of features that are just really, really hard to beat. Number two is obviously making sure that you export NetFlow from the right places on your network. Choke points are great. Like Paul said, if you want east-west traffic, it's always better to have more flows, especially given the algorithms within Lancope that will deduplicate and store those flows, so you don't necessarily have an impact to your overall storage. Even though you have more flows potentially coming in, you will have to pay more licensing because your flows per second are going to be higher. But it goes back to the discussion on where the real cost benefit lies for you particularly. Number 3, this is probably one of the biggest ones for us, making sure that we have that context within Lancope. This, wasn't necessarily the first thing that we did when we deployed StealthWatch. At the time we were just happy to have a system in place where we could sort of run those forensics queries and give people the UI that was easy to use. But this was the sort of the game changer for us. Having the zones from our network actually mapped into StealthWatch is huge. It lets you set up alarms with real context. Instead of having, some of the alarms fire that don't really mean anything on your network, you can only have them enabled in the zones that matter to you, and that's populated. So that's number 4. Number 5, this performance monitoring. To make sure that when flows stop coming in, you notice and it goes to either your network analyst or your SOC, so that someone can follow up and make sure that you don't lose those flows. Again, you don't want to find out that you've lost flows in the middle of an investigation, and that's bitten us a couple times. Number 6, again, this is up there with number 3 as being sort of a game changer, making sure that you have tools that can actually connect in through the API. It saves a lot of time. Just the simple use case that Paul mentioned where, the getFlows built into Splunk goes out and pulls the NetFlow. Lancope is already saving us lots of time with StealthWatch because for, say, one of those IDS events that fired with OSU FlowTools or NFDump, the analyst would have to log in, run the report, and it would take quite a while to run, so it's running faster within Lancope, but certainly just having that API built right into Splunk and having it be a simple click, and then you rely on all of the speed and quickness of the back-end database, but you never even have to leave the UI of Splunk is great for us from an efficiency point of view. And then number 7 is just training. There's one of the things that's good and bad about a system that's fairly intuitive and has a simple to use UI is that people can jump into it and start poking around and getting what they need out of it pretty quickly. But at the same time, there's often lots of ways to do something that isn't what you're used to, and it's actually more efficient and you can get more information out of it. Lancope has been really good about having webinars and training online and in person, and I certainly encourage everyone to take advantage of those. We found lots of times where people thought that something within Lancope StealthWatch was a limitation of the system, and what it actually was in most of those cases was just they weren't quite going about it the way that they should have been. And again, that's the problem with something that's fairly user friendly is there's several ways to do it, and sometimes there's a way that people aren't actually aren't aware of because they haven't gone through the formal training. So that would definitely be our last recommendation. With that, it's certainly been a pleasure. This is something that Paul and I love to talk about. So if you want to contact us, feel free to. We can geek out on NetFlow and Lancope stuff all day long. But with that, we wanted to make sure that we left some time for Q&A.